So now we are here to check the results. So let's just print with the F string notation our weight, and that is accessible with our tensor W and the function item. And we also want to show the bias, and that is stored in b.item. So these are the parameters that our model has calculated. If we plot again our graph, we can see here that we have our slope. The slope is -5, so you can roughly cross-check if that is making sense. It's easier with the bias. So the bias is the intersection with the y-axis, and the y-axis would be hit at 36.8. You have to consider that this is not showing all the way. It's starting at 1.5, so the 0 would be here. It's making sense. Okay, now we can also calculate our predictions. So for this we are just using our independent features x, multiply that with our weights, and to that we are adding the bias, and then we are detaching it from PyTorch and converting it to a NumPy array. So let's take a look at ypred. So these are our predictions. Now it's always good to have some visualization for it. So we are going to create some scatter plot. Here we can use our values which are stored in xlist and in ylist. So that is our true observations. And then if we put on some line plot for the same x values, xlist, and then we are taking our predictions that we have created. And then we are putting a line through it. And actually it's good that you see that. This is actually not working. We are ending up with some error. The data must be one-dimensional. Let's see what is happening here. So we have ypred. We can check the shape. And yes, it's two-dimensional. So this is something that you will end up seeing a lot. You have to always make sure that the dimensions of your objects are right. So one way to solve this is to call the reshape function -1 to remove one dimension, and then you can call it, now it's working. So this is now our regression line, which is actually coming from our deep learning model. So that's actually quite cool. If you compare that to the statistical model that we have here, it's basically the same. So even if it doesn't look like much, you have already created your very first neural network, and you were able to train it correctly, and it's providing the right values. That is actually awesome. You can just believe me, but in statistics it's always better to trust some numbers. So we can just make sure to see that we get the same results by creating some real linear regression model. So in here, this is just some sklearn stuff that we're doing here. So we are fitting our NumPy object x and p, and we are passing our target variable. And with this we create our regression model. And then we can extract our slope and offset. The slope is stored in the regression coefficient, and the intercept is stored in the property intercept underline. So let's see that. So the true values are for the slope -5.3, and the intercept is 37.28, And actually what we have here is coming very close to this, as you can see here. So the weight and the bias are pretty much what the statistical linear regression would also provide. Good. Then the last part, that is just bonus. So you don't have to do that because it's requiring some additional package installation. I have shown you this here at the end. So we can create a graph visualization of the graph that was used for this. For this you can use the package called GraphViz, which can be downloaded under this URL. But there are also some additional things to be considered. So if it doesn't work for you, it's definitely not a problem. I also had to do some changes just to make it work. But in the end, I just want to quickly show you that. Once everything is installed and you have added it to the path variable, then you can call the function makeDot from this package torchviz, and you get this representation of our graph. So this is the first neural network that you have created. We can see here which of the functions are called, which of them are depending on other functions, and so on, and all the way back to the very beginning, where we have the slope and the bias. So this was our first neural network that we have created. And from now on, we are building up on what we have learned here. So we are putting more complexity to it. We are going to improve the performance and the way our code looks. But the general structure is going to be pretty much like what we have seen here in this first lecture. So thank you very much for staying with me in this coding lecture, and see you in the next one.